compiling all of our survey on vending machine usage. We managed to get 44 responses from students all over the campus.
That's a solid sample. For our project, we are treating this as discrete data because the number of items known is countable. We can start from the number of factor.
Exactly, and since we are looking at individual responses of 0, 1, 2, or 3 items rather than range, this is officially ungrouped data.
Let's look at how we organize our raw survey results from the 44 students we surveyed across UMT. In our table, X represents the number of items purchased per week, and F is the frequency of students. We found that 6 students buy 0 items, 14 students buy exactly 1 item, and another 14 students buy 2 items. And finally, 10 students buy 3 items per week. By multiplying each value by its frequency, we get our Fs column, which helps us find the total number of items bought by the whole group. As you can see on the screen, our total frequency N is 44 and our total sum of items or sigma S is 72.
Perfect, let's get into the calculation. Okay, to find the mean, we use the formula sum x over n. With a total of 72 items purchased by 44 students, our mean is 1.64 items per week. That's mean. On average, a UMT student used the vending machine nearly first week. What about the customer credit? Interestingly, our data is by model. Both one item and 2 items are the mode. 6 will occur 40 times.
To find the exact center of our data, we calculate the median. Since our sample size n is 44, which is an even number, the median is determined by the average of the two middle values. By arranging all 44 responses in ascending order, we look for the mean of the 22nd and 23rd observation. Looking at our frequency table, the first 20 students bought 0 or 1 items, which places both our middle positions within the category of 2 items. By arranging these two values, 2 plus 2 divided by 2, our median is exactly 2 items per week. This indicates that 50% of the surveyed students buy 2 or more items, while the other 50% buy 2 or fewer. This central point gives us a clear view of student habits before we split the data further into quartiles.
Let's calculate the first quartile and the third quartile. So this is our data here. You can see we have item purchase, it's X, and frequency, F. So we can see that the 6 people purchase nothing, 14 people purchase 1, and 40 people purchase 2, and last one, 10 people purchase 3 items. So how to calculate Q1 and Q3? So before we can calculate the Q1 and Q3, we need to arrange this data first. I forgot to say that we need to arrange all the number that we have in the data, and we need to arrange it by the smallest to the biggest. So let's arrange it together. So we have 6 people that purchase nothing. So 1, 2, 3, 4, 5, 6. And we have 14 people that purchase 1. So 1, 2, 3, 4. We also have 14 people that purchase 2 items. So 1, 2, 3. And we have 10 people that purchase 3 items. So 1, 2. To make it less confusing, we will put this. So actually, if we want to find the first quartile and the third quartile, we will have to find the second quartile first. So that's why we will calculate the second quartile. So we want to find first quartile, but we need to find the second quartile first and then third quartile. So how to calculate the second quartile? It's very easy. You just need to slash, slash, and done. So let's slash together. Slash, 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 slash. Well, the slash, slash sound is unpleasant to hear in 3 times speed. Slash, slash. So, as you can see, we have 2 remaining numbers. So, we can count here that Q 2 is equal to 2 plus 2 over 2. So we have 2. So our second quartile is 2. To find the first quartile, second quartile, and third quartile, we use the same method. It just arrange and slash. So we take it here, and this is our first slash. Slash, 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 slash. Still the same, it's quite unpleasant to hear the slash. So, as you can see here, we have two remaining numbers. So, we can calculate the first quartile by 1 plus 1 over 2. So, we have 1. So, our first quartile is 1. Now, let's calculate. To find the third quartile, we use the same method as the first quartile. Slash, slash, slash. Unpleasant to hear the slash, 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 slash. So, you have two remaining number. The third quartile can be calculated like this. 2 plus 2 over 2 is equals to 2. So, our third quartile is 2. So, we already found our value for first quartile and the third quartile. So, our first quartile is 1 and our third quartile is 2.
Which means our interquartile rate is IQR is Q3 minus Q1, which equal to 9. But small IQR tell us that the below 15% of students have very similar habits, which is they almost all buy between 1 and 2 items.
To be precise about the dispersion, our variance is 0.981 and the standard deviation is 0.992.
Since the standard deviation is less than 1, it's confirmed that the student behavior is very consistent and it very close to our mean. Our survey also showed that water bottle is the most popular item in the residential, college, and the home location. This highlights the biggest benefit, which is convenience. The students don't have to walk far from their hostel for essential drink.
Don't forget 24/7 accessibility. When the temperature is close during late night study sessions, these machines are a lifesaver.
Exactly, since water is taught to just these machines are vital for student hydration and study focus during lectures. So we got our mean of 1.64 by model code and a very consistent standard deviation.
This was way more interesting than just looking at random numbers. Statistics actually explains our campus life.
Exactly, it's impressive how the survey of 44 students reflects our actual needs at UMT. We shows that statistics isn't just a textbook, it's a real world tool for understanding our campus life. Oh! So that's all from all of us, and I'm